Afternoon, everybody. Hopefully I am coming through loud and clear. If you came here for a really exciting talk that's going to get you out of your seats and cheering, then I think you're at the wrong place, but we're going to try to make it somewhat interesting. I have recorded about 100 hours of NFPA meetings, and you can just sit and watch them here live time. I'm sure you'll find that really exciting. No, not really. I'm here to talk about the NFPA 1983, which is the standard on life safety rope and equipment for emergency services. The last edition came out in 2006, and the newest edition was published in January of 2012. It's we'll talk about this at the end, but it's going to go in effect officially at the end of this year. But everybody's scrambling to get certified to this to the standard right this minute. And there's a lot of changes, and I think that's basically what I'm going to talk about. If it's something that's already in the current standard, it won't be much that I'm going to talk about. But I'm having a technical problem. I cannot get it to advance. There we go. All right. It decided to work. My disclaimers to start with: that I am on the committee, and I've been on the committee for a long time, but what I'm saying is purely my opinion of what the changes are. I've skipped a lot of the little minutiae. Obviously, every time you change something, the labels change, and a lot of things like that change. I'm sure not going to go through how the labels look different or things like that. If you want to know all that stuff, you need to get a copy of the actual standard, and I'll have that at the end of the talk here. There's also, you should know that there were a lot of issues with this publication. There's a TIA, which is a technical interim amendment that's been proposed out to fix some of the problems. There's also probably going to be an errata sheet out to fix some of the editing issues. I can't really begin to tell you how many frustrating little things didn't get fixed by the editors. It'll probably be a couple of months before those things are available. But if you check back at the NFPA site, they'll be able to help you on that. So what is new? With the scope and purpose is kind of pretty much what the document's all about, and these things have been added to it this time. Now we have escape systems. You may have thought there were escape systems before. There were manufactured systems, but they weren't specifically escape systems. And so there are some new requirements we'll talk about later. Eye terminations. You've probably been buying NFPA ropes with some type of a sewn eye or a swaged eye or something like that, and just assumed that that was part of the standard, but it hasn't been in the past. So you were pretty much on your own to make sure the strength was what it should be, and every manufacturer had a different interpretation of what those strengths should be. We've tried to fix that. Moderate elongation life-saving rope, that's basically what used to be the New York City Fire Department's roof rope, laid rope. They wanted to get an NFPA label for it. It's specifically called life-saving, not life-safety like the other ropes, because it is very different, has a different elongation, and obviously it's laid versus mostly Kerman or other designs. So we'll talk about that. Belay devices. We never had a standard for belay devices before, and so they're included in this document. Victim extrication devices, that would be anything to pull somebody out of something. They're basically a harness designed to pull somebody out of something. Litters are just that. They're mostly your basket litters. Never was a standard on those before, and it was something sorely needed. Escape webbing. If you're in the fire service, you've probably seen a lot of people selling escape systems that had something that looked more like webbing than rope, and the standards people were always confused about how do you call something rope that's not round. And so we actually came up with a new product called scape webbing, which is just a way of trying to get this certified without actually calling it rope. Escape anchors are exactly that. They're the anchor that goes on the end of an escape system. Other major changes: we added flame resistance requirements for harnesses and belts. Some people were making different harnesses and claiming them to be FR, but there wasn't a test for what that meant specifically. So flame resistance is now part of the testing for belts and harnesses that claim that. Three-strand model, we talked about the three-strand life-saving rope already. Another big difference is descenders. In the past, to be a NFPA descender, it was pretty much just a rock down a rope. You could take almost a ring and drop it down a rope, and because it was all about tensile test and not really about whether or not it worked. And so there's a bunch of performance tests that have been added for descenders. The big changes for a lot of people, it's a big headache for manufacturers, but the users really asked for this. They thought that the term light use was construed by a lot of people to be negative, and we've come up with the term technical use, because a lot of stuff, just because it's lighter weight and maybe not quite as strong, doesn't mean that it's not perfectly good for use by people who know what they're doing. So for the gear where someone actually understands things like what the forces are and what the force multipliers are and what the design loads are and what the safe working loads really are, safety ratios of the system when it's complete, you can calculate all that, then technical use makes is a better sounding word than light use. Of course, that means everybody's got to redo their gear and mark everything again, but so it be. Once again, I'm having trouble getting my computer to progress. All right, let's see if we can do it this way. Definitions added or updated. Belay systems, belay devices, escape descent devices. These are all terms that basically we added to the definitions. If you're interested in them, you can look at them in the document to see exactly what they're calling. In some cases, I've included them in the talk later on, but these are all the new things. Victim extrication devices, escape systems, both fire and non-fire. We'll talk about that in a minute too. And some other things like load straps. There was some confusion over how they were tested, and because some of them were end-to-end use only, and some of them were made to be multiple configurations. So we've now actually broken them up into two sets. Terminations we talked about. Fire escape rope is just, we had escape rope, but we didn't really have a specific thing called fire escape rope, which had a temperature rating in it. We talked about the technical use being what the old light use was, and that's exactly the same definition, just what the term is now. And then I talked about the difference. There's now a escape webbing and a fire escape webbing, the difference being at the fire tests. I'll show that here in a second. So life safety ropes, which is what the whole document started with, the original 1985 publication of this book was pretty much all about ropes and had a few paragraphs on hardware, and now it's become 60-something pages, and there's probably 3 or 4 pages on rope at most, and a whole bunch of different kinds of ropes. But the basic rope that we all have used for years, such as the PMI classic ropes and stuff, there's no major changes other than what used to be L will now be T on the ropes. Harnesses. There's no more class 1 harness. I'm sure that's going to make lots of people sad. That was the 300-pound design load seat harness. The certification people said no one ever certified a harness to that. It just didn't make any sense. They were all going for the class 2 and 3. You may remember that class 2 is a 600-pound design load seat, and a class 3 is a 600-pound design load full body harness, basically. So 2 and 3 still exist. Class 1 is gone. We chose not to reduce the numbers back down to 1 and 2 to keep from confusing people. So it starts at 2 and ends at 3. I hope that's not too confusing for the world. Flame-resistant harnesses and belts must be made with FR sewing thread. I guess that's pretty obvious, but they put stuff in the standards like that, and because if you don't, somebody might not. And they do that because they actually test the parts, the webbing and materials individually for flame resistance. They have an elaborate test system for doing that to see if it melts or drips and all those other things and burns up, and they test the parts one at a time. They don't put the whole harness together and set it on fire, which is good for us because it would cost even more to do the testing. So that's why they say that the thread must always be FR as well. The victim extrication device. This is basically something to pull somebody out of stuff. The definition of a class 2 victim extrication device is that it's basically made to lift you straight up. And so it's tested in a straight up position too. And there are a number of those on the market already. I'm sure a lot of you guys can think of a whole bunch of things that have been out there, but there's never been an NFPA standard on that. A lot of people claim, well, ours would be a class 2 harness, or ours would be a class 3 harness. Should there be a standard for this thing? And people were sending in some of these devices to be tested as harnesses, and the labs are saying, well, this doesn't really look like a harness. So now we have a class and a test for it. So as I said, the class 2 is basically pulling them straight up, and the class 3 is made to be basically drug horizontally or pulled horizontally and upright. And it actually, when we get to the test, you'll see that it's tested in those configurations. So the class 2 one, the load's applied upright, and it's got to hold 16 kilonewtons without basically dropping the mannequin out of it or having more than an inch of slip in the webbing. So that's the simple basic test for it. There's some other requirements very similar to the harnesses about the types of webbing that can be used and stuff like that to make sure that people aren't using polypropylene webbing or some other kind of inferior product versus the same kind of stuff that's in the regular NFPA harnesses. On the class 3 device, it's tested to the same 16 kilonewtons head up, but also has a head down horizontal drag type position, which is 10 kilonewtons. And this is pretty simple stuff here, but it's good that we have this now because there's a lot of stuff out there on the market that's of various quality, and a lot of people are picking up people more than a couple of feet off the floor with some of these connectors, and they don't really know what the strength of these things are. Now we'll have some rated gear for it, so this is a good thing. Litters, it's another thing that's been around forever, and a lot of us have been using them, and they're all over the board. And testing the original military Stokes basket had to hold I think it was 2,400 pounds, but it was you filled basically the litter was shot statically, and you picked it up on the 4 corners straight up, not like a bridle would pull them into the center, but straight up. And so the litter test was fairly easy to pass with a metal litter because you didn't really do anything with it or pull on it very hard to make it collapse. And of course the plastic litters and stuff would never handle that much load anyway in the old days. And some of them are still pretty flimsy, but there wasn't any kind of NFPA test or really any serious litter test other than NFPA, other than the mil spec for the original World War II military Stokes basket. So now we have this one. It has to hold 11 kilonewtons without failure or deformation of the structural element. The big difference is if you get the ASTM F32 standard on this litter testing, you'll see that it's handled with a 4-point bridle that pulls in the middle so that the angle actually is trying to fold the litter a little bit, and the force is pushed into the bottom of the basket, so it's a much tougher test to make sure that the litter will hold up, and especially on a 2-part litter where you've got that connection point across it. So this is another, I think, good thing, and you'll be seeing people with litters that meet this spec out pretty soon. Scape webbing, there's nothing special about it. It's pretty much the same requirements as rope. It's got to be virgin fiber, block creel construction, which means that all the yarns are basically unspliced. If you run out of a bobbin on a machine, you have to stop the production and start back up again versus just changing out 1 or 2 of the bobbins. The same thing with the fiber. It has to be basically continuous. For those of you who remember some of the rope talks I've given before, the definition of continuous is there's no real easy way to tell where one filament begins and the other one ends because the filaments are so long, and sometimes thousands of feet long. The same performance requirements for escape rope apply to the escape webbing. The only real difference is this thing you see below, which is how you determine the size of it. That's what the problem was before, was when somebody brought up a webbing and it said it had to be 7mm in diameter or 8mm diameter because they were trying to get it to be approved as rope for escape systems. How did you measure something that's flat and by the CI test standard? So they've modified the Cordage Institute test standard here. You'll see where it basically now they measure the perimeter of the webbing, and it has to be a minimum of 25mm all the way around the perimeter. So it could be, I guess, paper thin and wide, 12mm wide, or whatever it takes to make it, but still has to meet the MBS and all these other things of what the escape rope was. And there's also a fire escape webbing, and it's the same as the escape webbing, except they've added this temperature test, and you may hear some people whining about this, but there's no reason it shouldn't pass. Basically, there's 2 tests. You hold 300 pounds for 45 seconds at 600 degrees C, and then do a second test on a new piece of rope, 300 pounds for 5 minutes. At 400 degrees C. And for those of you who know about these aramid fibers, the 600 C is actually above the zero tenacity point or the failure point of the Kevlars and Technors and other kinds of aramid fibers. But the difference is that the 45 seconds gives you a really good idea of what happens in a flashover type fire or something, and because there's some mass to the webbing or the rope if we're doing the rope test, and it takes a while to get up to temperature. And so far, all our testing shows that a good quality product should pass this test and does pass this test. Escape anchor devices. Here's a couple of ideas of what we're talking about. The Crosby hook that's in the New York City department. A lot of you guys might be familiar with that. These are 2 more that are out there. There was no minimum tensile strength requirement on it before, and basically it's up there with about the same number as the escape rope itself is. So it has to mechanically be this strong. And as I said, there's just like the fire escape webbing, there's a fire escape rope now. We've had escape rope for a long time, but there wasn't any specific test for the ones that people were claiming were, fire escape. They just said, well, this one's made out of Kevlar, so it won't burn. Well, as everyone should know, yes, it's true, Kevlar doesn't burn, it just turns into carbon and falls apart. So what temperatures that happen at, it actually happens at not that high of a temperature anyway. It's higher than nylon by a good bit, but it's still not going to be there in a long direct flame impingement fire for a long period of time. So we added this test to give it some numbers to go by. This is a minimum requirement for the test. Escape systems. This is, some people in the past we had, or there is a part of the old standard that has manufactured systems, and they were kind of like anything you wanted to build, and they had only a tensile test on it, and a lot of departments were unhappy with some of the stuff that was coming out and being sold as escape systems, that it didn't have all the components up to snuff, so to speak. So now the new escape system has to be made up of components that under themselves are passing this NFPA. If it's the rope or the harness, the hook, all those pieces have to be already certified. Plus, when you put it all together in a system, there's a couple of tests. One of them is this tensile test. Still has to do the 13.5 kilonewtons. There's a payout test, which is, I think, really difficult, but this is what a lot of the guys wanted, the users, and this is that you have to be able to walk backwards or crawl backwards, I think it is, pulling on the device with no less than 20 pounds to get the rope to run through it. So like if you're in an apartment that's on fire and you've got your escape device anchored to one wall and you're trying to get over to the window, then it only takes 20 pounds of pull to feed rope out through it, so you can get quickly to the edge of the windowsill or whatever you're going to escape from. 20 pounds. There's also a system level drop test, which is what a lot of people want to do, is that if you roll out the window, you're not going to hit the rope with more than 8 kilonewtons of force, so that you won't see it, anchor won't see it, hopefully the rope doesn't see it any more than 8 kilonewtons. And that may require some people that are using the pyramid type ropes, they may have to put an energy absorber in it, or they have to design a descender that slips a little bit, or some other way to absorb energy. That's kind of up to whoever builds the system as to how they're going to achieve that number. Fire escape systems, same thing again. It's just one where you've sold it and claimed it's FR. I think, as I said before, a lot of people kind of overestimate the ability of the FR ropes and what they can do. They just buy it because it's what they think they need, and we needed to put some numbers out there. So here you go. It's basically the same test as the webbing, and the rope itself is tested, but the system has to pass the test. And it's no big surprises here if you understand the rest of it. It's just saying that the whole system has to do the same thing for high temperature that the webbing and ropes do if they're the fire version of it. And the reason there's still an escape system that's not fire escape is there are a lot of people that bail out of things that aren't necessarily on fire for various reasons, and NFPA wanted to be able to still have an escape system for those people that's rated for strength and stuff. You could be in a bucket truck that's just broken down and you need to get out, and maybe you don't need maybe if you're not a fire person, then maybe you don't need a rope that's fire rated just to get out of that. Or maybe you do, and it gives you the choice of picking which one you want to buy by naming which system you want to add certified to. Manufacturers supply eye terminations. Those are basically, like as I said, they're either swage fittings or, as the picture is here, sewn terminations in the end of the rope. There was a little bit of bickering on this in the committee, but what the strength should be on these between different manufacturers. Most people, I think, just assumed if you had an eye in the end of the rope that the eye was 100% of the strength of the rope. If you said it was a 9,000-pound rope, then the eye had to be 9,000 pound too. Unfortunately, some people interpreted it otherwise. They would get their rope certified at 9,000 pounds and they'd go back and make an eye, and they wouldn't get that retested or even tell the customer what the strength is. So now we're telling you what the strength is, and it's a little confusing. It's all here in this chart. Sorry, but this is what it took to make everybody happy. The base number is in red, and that's it. If you buy a 9,000 pound G rope, the eye has to be not less than 85% of the certified rope's calculated minimum breaking strength. It means if you buy a G rope that's actually 10,000 pounds and you take the 15% off of it, you can list that number as what it is if you want to show something a little bit higher than that, but the 85% is the bottom. And just like if you'll see, you have to have the minimum breaking strength of at least the 40 kilonewtons, no matter what, for that rope. So you would have to have a rope that was one of these things. And it's a little crazy, I admit. Moderate elongation laid life-saving rope. As I said before, this was typically the New York City type roof rope that their ladder trucks carried for rescue, where they go to the roof and rescue people, and they've been trained on these for decades and decades, using these 3-strand laid ropes to effect rescues out of high-rise buildings. And they've never had an NFPA standard that they could meet because of the difference in the elongation that 1983 ropes used to call for. And so we've added this thing called moderate elongation to allow them to have a place to be certified to. And it's basically the same basic requirements of materials like block creel construction, virgin fiber, continuous filament fiber, but it's a laid rope, and it's going to be stretchier. And here's the numbers for that. It's still got to be 40 kilonewtons. The minimum elongation shall not be less than 1% at 10% of breaking strength, which isn't any different, but the maximum elongation goes all the way up to 25% at 10% of breaking strength. So that's the big change there. And then the diameter range is from 11 millimeter to 16 millimeter. There's not an L or G. It's just there's just one rope that falls into this category, and it has to be, the fiber has to be a melting point of 400 degrees F, which is the same thing the other static ropes and low stretch ropes have to meet, which is basically nylon, polyester ropes like that will pass. So if you all want to rush out and buy laid rope, I'm sorry to hear that, because we don't make one. But there are people out there that do, if that's what you want. I talked a little bit about manufactured systems. Other than taking escape systems out of manufactured systems, for sure they have to be under escape now. We added a couple of things just to make sure that if you were building a manufactured system and you put a component in that system that was a harness or a belt, that it had to be a compliant harness or a compliant belt. I actually think it says the same thing for rope, that it has to be a compliant rope as well. Descenders. This gets a little confusing, but it's going to be good for the users in the end, I think. Hopefully everybody won't hate us for it. Descent control devices are now classified per an ISO standard that was written in, I think it's published in 2007. It's ISO 22159, which is personal equipment for protection against falls, descending devices. And they classify these different modes of descenders from type 1 through type 6 Type 1 is a total automatic one. We don't address that here. It's not something that I suspect we'll see a lot of in the fire rescue service, so we don't really address it. Type 2 are manually operated descending devices with an integrated descent line. There's some of them out there now being sold into the fire rescue service, and so they're called Type 2s. Type 3, mechanically variable friction version of a manually operated descending device. It's hands-free locking and panic locking features. Type 4, manually operated device with mechanically variable friction hands-free locking. And you can read all these things. They're just different variations of whether it has panic lock, hands-free locking, whether it's how it works. Don't know that anybody really cares if you walk into a store and say, I want a brake bar rack. They'll still probably find you a brake bar rack, but it's going to be a Type 5, I think. I see manually operated descender device with mechanically variable friction and non-automatic locking. Yep, that would be a brake bar rack. So what do we do with that information? Why did we type them? Well, it was so we could do these tests. There's a specific hands-free holding test to see if it really is auto-locking. If you let go, does it really lock? Does the stop? There's a panic lock. Some of them claim that if you squeeze it too hard or do whatever it is to make it go too much, you're in a panic, then it'll lock as well. And so there's now a test for the panic lock. And then if you just claim that it locks on its own, then there's a simple holding load locked test. And those are basically even a rack can be locked off. So it gets tested to that last locked test there. So those are the new tests. You can you have to kind of get both the ISO standard and the NFPA 1983 if you're a manufacturer to kind of figure out exactly how all these go together. But chances are, if you're a manufacturer, you've already got both of those anyway. Belay devices. This one got really screwed up in editing, and it's really hard to understand exactly what's going on. All I can do is apologize for this. There's a technical use belay device and a general use belay device. The technical use belay device is, it says it is tested per the manner of function tensile test, but the truth of it is that if you look at procedure C, it's the ASTM drop test. So it's actually a dynamic drop test, and you do this drop and the rope can't fail or the device can't fail or come off the rope. And the technical use one is 300 kg, which is 300 pounds, dropped from a 60 centimeter height on a 300 centimeter piece of rope. And there's supposed to be an impact force requirement, and it doesn't actually say what it is, though I think that everybody's going with the G impact force at the moment just to seeing how it's a maximum do not exceed number. They're just using that number for now. I'm not sure how that'll wash out in the TIA. Here's a general use belay device, which, as I said, it's the same procedure. The difference is it's 200 kg, which is 600 pounds, same drop, has a maximum extension and a maximum force of, it's got to be under 15 kilonewtons, which would be a lot on a single person load, but on a two-person load, it's not so terrible. And I believe that that's the part that's missing, is that the single person, the technical use, I should say, should be closer to half this number. And hopefully that'll get fixed here real quick. And here comes the bad part for the manufacturers. The effective date of the 2012 edition was January 2nd of 2012. We can't label products that are certified as compliant with 2006 edition after January 2nd, 2013. So we all have to either be recertified to the 2012 edition and have everything labeled up by then, or we got to quit selling it. If you can relabel stuff, if you can get it retested, then you can relabel stuff that's been made earlier, but it has to meet all the requirements, including all the labeling requirements. So you'd have to retest it to the new standard as the same exact product to be able to relabel it. But that is one possibility if you've got some inventory of stuff you won't get rid of before the end of the year. And then we're actually supposed to remove all certification labels and product labels indicating compliance with the 2006 edition as of the end of this year. And that's what I was just saying. You can relabel them if you have to. Now, does that mean that dealers have to do that? Absolutely no. Distributors, no. It's just the manufacturer, the guy that's inspected by the UL inspector. He's the only guy that has any control over it. He's supposed to take up all the old labels and say you can't use these anymore, and make sure your inventory is all cleansed at the end of the year. That's only at the manufacturer's level. You distributors and dealers and users, the stuff is still perfectly good to use and to sell and to own. And just because it's got a new label on it doesn't make it any better necessarily. As you see, most of the stuff that's being currently labeled didn't change anyway. So it would really only affect you if you really wanted to make one of these or purchase one of these new products or sell one of these new products. So that's it in a nutshell. How do you get a copy? The NFPA website, if you put a backslash and the standard number, it'll take you right to a page that allows you to see everything about that particular standard. If you don't want to do 1983, if you want to do 1670 or one of the other NFPA standards, you just do the same thing. www.nfpa.org / and the standard number. It takes you to that documents page. The first tab you look at is the document information tab. And a new thing recently is that you can view the document online, read only, and you go down to the bottom and you click on that, and it makes you swear that you're not going to do evil things to it. But then you can actually look at the PDF copy of the document. It won't let you print it and it won't let you copy it, but you can look at it. So if you want to read things like definitions to see what they say, you can go online. It doesn't cost you anything. I say this, I hope I'm right. You don't have to be an NFPA member to do it. I think it's open to anybody. So the worst case is you can look at all of them for being an NFPA member, but I'm pretty sure that it's open for anybody to see. You can also purchase these on paper or PDF at the same place. There's a link to buy it on the same page. So if you're really into these things, then owning a copy of it's useful. I would probably wait to see where the errata and the TIA go to make sure you get to all the latest info. It should be solved within 2 months. I would say by end of November, early December, you should be able to get whatever comes out of it all. So that's it. And Jessica, I'm ready for any questions.
Alrighty, I'm going to change the screen back over. And if you do have any questions, I want you to go ahead and type them into the chat/question section of your control panel, and we'll get them answered for you. So give you a few minutes to do that, and
it says there's people still out there, so I know everybody didn't just go home.
Yeah, there's still a bunch of you here, so ask your questions. Yeah, I'll give you a few minutes to type them in, and while you're typing your questions in, I will go ahead and go through the basic kind of follow-up information for you guys. You can view the recording of the webinar on our website, like I said before, and there's also going to be a link there to email Steve. So if you have any further questions that we can't get to during this webinar or that you think of later, you can definitely email him, and then you can also download the slides from the presentation at that link, and that's where the live recording is going to be as well. The webinar series we host frequently, so keep an eye on that webinar or on the website for the future webinar dates and topics. And then for future updates for webinars and also everything else PMI, everything that we're doing and what's going on around here, you can follow us on Twitter and Facebook, and you can also sign up to get our newsletters. And we don't spam you, I promise. And we do have a couple of questions. So the first one is, could you please explain in layman's terms the difference between the BCCTR Belay Drop Competency Test Method and the new Belay Test Method in this version of 1983?
Not much. Is that layman enough? The ASTM F32, which is the actual drop test itself, that committee basically took Arner's original BCCRT test method and kicked it around for years with Arner, and then he wanted it to not only be a drop test method, but he wanted it to be a pass-fail, and the ASTM folks just took out the pass-fail part and put in basically the test method. So it's pretty much the same test. If you've seen it written up, you can get that from the ASTM as well. And if somebody needs a link to that, I can give them how to find the test method for that one for sure. But it's pretty much the same thing.
Okay. And the next question is, what was the MAF requirement for the escape system level drop test?
Ooh, there's that one I'll have to actually look up. I think it's the same 8 kilonewtons, but it might be 6. How's that for a WAG off the top of my head? Let's see if I can find it here. The idea, again, was that they didn't want to bust some of these escape ropes that have 0 elongation. And so let's see if I can find it here. Unfortunately, I may have to get back to you on that one if you send me an email. But if nobody else has got another question, I'll keep looking. Maybe I should sing something.
The only other question is, can we get the ASTM standard without paying for it?
No. Those people, all standards people, are in the business of selling their standards to how they keep their doors open. So unless you have a friend who's got one, or your team is a member, which is absolutely the cheapest way to do it, you can buy an ASTM membership for one person, like a team, and with that membership comes a volume of your choice of all of their standards. So you can get all the search and rescue, technical rescue standards for the price of being a member every year, which isn't a bad deal, especially if you've got 10 people that are sharing it. It's a great question, and I don't see the answer to it. So I'll have to get back with you on what the force is.
Okay, I will actually, let's see who asked that question. Kyle, I will actually forward your question on to Steve via email, and then he can reply to you. We do actually have one more question. If an end user already owns equipment that has been changed in this standard, can they continue to use it, or does it need to be replaced? For example, brake bar rack, victim extrication devices, etc.
There's absolutely no reason not to keep it as long as it meets the original design parameters that you needed when you bought it. If it was something that there wasn't in the standard, like a litter, then it's you have to just go by whoever bought it to begin with and what condition it's in. If it's a piece that was previously NFPA labeled as let's say it was an L rope yesterday and tomorrow it's a T rope, then it's perfectly good just for whatever the life of that particular rope is based on your use. So the answer is no, there's no reason I'll replace anything. As a manufacturer, I'm sure, and I see there's a couple of guys on here that are manufacturers too, they're probably all cringing, no, make them buy new. But no, the truth is that it's fine, it's perfectly good. There's no reason to replace in-use stuff until it's worn out, and stuff in your inventory until its life expectancy is up per the manufacturer's life requirements. If you see something that you wish you had, like an FR harness or an FR escape rope, and you don't know how well it is FR, at least I would do is go back and ask the manufacturer of it, hey, does this rope that's in this escape system you sold me last week, does it meet the requirement that's in this standard? They should be able to tell you. Any more?
Okay, great. I don't think there were any more. There is somebody that is requesting your email again, so I'm going to actually switch it back over to your screen so that they can see your email, if that's okay.
Okay. Should be back up.
Yep, there you go. All right, so there is Steve's email, and that email, there'll also be a link on our website to email him in the future. And so if you have any further questions, feel free to email him, and definitely check out our website for the slides to the presentation and the recording and for future webinars. So we really appreciate you guys coming to this, and we hope that it was informative, and thanks, Steve, for doing it.
Yeah, and thank you all for taking your time off, and to all of you men and women out there that are part of the emergency services, special thumbs up for the 9/11 today. Thank you all for your service.
Yeah, I'll second that. Thank you all very much. And everyone have a great day, and we'll see you at the next one.